Open your book to page 2. Today's lesson is on the relationship between angles, degrees, and arcs. So first, let's look at over the angles. Okay, an angle is made out of a vertex, which is a point, and two rays. So this is a ray. Okay? Everybody know the difference between the ray and the line, right? This is a ray, right? And this is a line. The line goes on infinitely on both directions, so quick review. Okay? And so an angle is made out of a vertex and two rays. And this is angle theta. Another way, sometimes different books define it differently. Sometimes in this book, it defined as a ray and it rotates to certain degrees. So like this one, if you have the ray and you rotate to that. Okay, so that's how this book defines. But it doesn't matter either way. But as long as you know what an angle looks like. And the part that you start out, this is called the initial side. And the side that you stopped, that is the terminal side. And the word terminal means the end, right? So if a person is terminal ill, means the life is going to end, right? So think about the word terminal, right? So again, terminal means the end. So that's where it stops. Okay. Now, also you need to know which direction is positive, which is negative. So when you go this direction, it's positive. Okay. If the angle, if you go in this direction, is negative. So as you can see, it's important to know math, because if you look at the clock, see, the inventor of the clock didn't know math, so it went in the wrong direction. Okay? Okay, and let's go to page 3. The next term, notice all the important terms are in blue color, right? So when you look at a page, when you see something blue, that means it's important that you need to know. So next term is called coterminal. Coterminal means the angles, they have the same beginning and the end. So for example, you have this angle, and you have this angle going like this. So these are coterminal. So in other words, what I'm saying is that 30 degrees and 390 degrees, so they are coterminal, because so what this one does is that this go around circle one extra time compared to these. But they will have the same beginning and same end. Both will have the same beginning and same terminal side. Okay, but they are different numbers. So this is called a coterminal. Means if you put one on top of the other, it will become identical. But the number of degrees will be different because this go around extra circle. Now to get coterminal is very easy. You just keep adding 360 or minus 360. So in other words, you can go backward. So you can have a negative 330 degrees, and you will have the same. You will have the same degrees. So if you go backward this way, right? So all these three angles are coterminal. If you put one on top of the other, they will become exactly the same. Again, all you have to do is keep adding 360 or minusing 360, because every time you add 360 means you go around circle one time, right? If you minus 360 means you go backward one time. And you can keep adding it. So there are infinite number of coterminal, right? You can keep go around the circle. Each time you go around the circle, you can add 360, right? So the next one would be 750, right? Right? You keep at 360, so you get 750. That's how I get that, right? So you can keep adding 360 or minus 360 to get coterminal. Okay. Now let's look at the bottom of the page 3. Degree measure of angles. So normally you can use a protractor to measure. So this is the protractor. Right? So let's say if you have an angle, just put a random angle, and you're going to measure how many degrees is that. You put this right over here and line it up, and then you read off, and so it's like about 49.5 degrees. So this is 49.5 degrees. So use protractor to read. Okay, so that's how you measure the angle. Now, if you look at a picture, if you have a circle, and if you start at any point and you go to a complete circle, okay, it's 360 degrees. And also on the picture over here, it shows you kind of have an idea how big 1 degree is. So I'm going to draw 1 degree. Okay, I'm going to use this to measure 1 degree. So 1 degree is right over here. That's 1 degree. Okay, so just give you an idea how big a degree is. Okay, let's go to page 4. Again, all these are review from your geometry. I think all of you should kind of have some kind of idea what we're talking about. Okay. You probably don't remember everything, but as we go over, it kind of should refresh your memory. On page 4, there are classifications of angles. So if you look at A, so A is acute angle. The word acute means sharp. So look at this corner. It looks like imagine that you have a knife like that. It's pointy and you can jab somebody, right? So it's very sharp. So that's what the word acute means sharp. Okay? And so this is between 0 and 90 degrees. Okay, so it's greater than 0. So what happens if it's 0 degree? Well, if you have 0 degree, you got nothing, right? So that's why you have to be greater than. Because if you have 0 degree, you don't have an angle. Okay. And this is the Greek letter theta or th, right? Okay, so theta. Okay. Now you go to the next one. Normally when you have right angle, you have this little square symbol over here. So this is the right angle, and it's 90 degrees. You go to the next one, obtuse. Obtuse means blunt, means not sharp. Okay, so this is an example of that. So you can notice this corner is not very sharp like this, right? And so this is greater than 90, less than 180. And D is a straight angle. So it's just a straight line like that. Okay, so this is 180 degrees. So just be familiar with all those classifications. Okay, let's go to the next 2 terms. You have complementary and supplementary. So when you have 2 angles, angle alpha, angle beta. So this is a Greek letter A, Greek letter B, right? Alpha, beta. So when you have alpha plus beta equal to 90 degrees. Now they don't have to be next to each other. You can have one angle over here, and you can have one angle way out here. Okay, as long as they add up equal to 90, then they are complementary. Again, they don't have to be, but like next to each other like that. So this is the complementary. The next one is supplementary. Okay, that is when you have 2 angles. So you have alpha plus beta equal to 180 degrees. So again, all these are very basic stuff from your geometry. You should know this. Okay, now let's look at the next 2 terms on bottom of page 4. This is how you measure the angle. Okay, so you have the DD. So this is a decimal degree, and you have another term, it's a DMS. So this stands for degree, minute, and seconds. So example of the decimal degree would be like 12.25 degrees. Okay, so this would be decimal degree, using decimal. Now, degree, minute, and second would be like 12 degrees, like 30 seconds, and 20 minutes. Now the way this works is just like the clock. Okay, so degree is like hour. So 1 degree is equal to 60 minutes, and 1 minute is equal to 60 seconds. So this is degree, minute, and seconds. It's exactly just like the clock. Okay, so the degree is just like the hour. So like this is like a 12 hours, 30 minutes, and 20 seconds. Okay, so it's the same way. Now to do the conversion between one to the other, since everybody has calculators, so I'm going to show you later on how to use calculator. But because there are so many different varieties of calculator, so after I give you assignment, I will come around to help you individually how to convert from one to the other. In the book, you kind of do it manually, but we're not going to do that anymore because, I mean, why do that when we are calculating? Just push button, right? So make a good use of technology, okay? So, see, you guys are very lucky. You know, back in my days, calculator was not even invented yet, so we have to do it manually, everything manually. There was no calculator, nothing, okay? And, you know, like Mr. Sakura just mentioned, you know, today during the chapel, right? 6 years ago, there's no iPad. So technology is changing, so, you know, life becomes a little bit easier. Okay, now let's go to page 6. How to calculate the arc length. So you have a circle. And you want to figure out the length of this over here. So this is called an arc, right, from your geometry. And the symbol for arc is S. And here's your theta. Now there are different ways. I mean, there's only one formula, but there are many ways of come up with that formula. And so it doesn't matter which way you remember it, but instead try to, as you get into higher math, try not to rely on memorizing things. Try to understand and figure things out. Okay. So as you know, circumference is equal to what? 2 pi r, right? Now, the way to do this is you apply, again, from your geometry using the proportions. Okay. So you have the circumference out here, right? C for circumference. So what you can do is using the ratio. So you can have the theta, right? The partial angle over the entire circle over 360, right? So again, the partial over the entire circle will equal to the part over entire circle, right? Again, part over entire circle equal to part over entire circle. Okay? Okay, remember in geometry, right? You can write proportions in any way you want as long as you match things up correspondingly, right? So this is one way of doing it. Now another way of, instead of matching these, okay, instead of matching the angles, what you do is matching up the sector by itself. So what you can do is you can have the angle over the length. See, angle over length will equal to angle, which is 360, over the length, which is circumference, or 2 pi r. Right? So you can have the angle over length equal to, so partial angle over partial length equal to the whole angle over the whole length. Right? So you can use proportions. Okay? So you can use any way you want. Okay? Another way you can do this is by more logical approach. What you want to do is, this portion over here, first what you do is figure out the entire circle. So it's 2 pi r, right? So get the entire circle first, but you don't want the entire circle. You just want this part of it. So you only times by the portion that you want. So it'd be theta over 360. Okay? So you can first you figure out the entire circle, then you times by only the part that you want. Okay? So again, so it doesn't matter which method you use. Best to do is know all three, right? But just figure out whichever is easier for you to understand, which is easier for you to remember, and then you'll be fine. Okay? So just use one of those. Now, it's also true, so that's for arc length, but it's also true when you're looking for area. So this is like a slice of a pizza, and this is called a sector. So again, a little bit review from your geometry. So this is called a sector. So the area of the sector, again, there are many ways you can memorize this, right? So this is the area over here. So I'm going to call this A. Okay, so the area of this sector is A. Again, so you can do the ratio, right? So you can do the area over the angle equal to the area. Area of the circle is pi r squared, right? Over the angle. Everybody see that? So you can partial area over partial angle equal to the whole area over the whole angle, right? Or you can match it up. You can have the partial angle over the whole angle equal to partial area of the whole area. Right? So it's just like what we had before, right? So you can rely on understanding how we get these, and that way you don't have so many things to memorize. And another method, like third method, the area, first you figure out the entire circle is pi r squared, right? So first you get entire circle, but you don't want the entire circle. You just want this part of it, right? Well, if you want just this part, then you times by the part that you want, which is theta over 360, right? You just want this part out of the entire circle. Well, that's that, right? So again, they are all the same. Okay, they are all the same equation, just written in a different configuration. Okay, they're all the same. So you can take your pick, find one that is easier for you to remember, that one is easiest for you, and just use it. Okay. Okay, so let's do example 3. So let's go to page 8, and let's do example 3. It says how large an arc is subtend. So the word subtend means how much the arc cover, how many degrees it covered. So what it's saying is that this arc, subtend means it covered this many degrees, so 6.23 degrees. So this arc subtend 6.23 degrees. So that's what it means. And with a radius of 10 centimeters. Okay, so you're looking for S. So you can use any one of those three methods. I'm more used to, logical approach instead of using ratios. So I'm going to get the entire circle first. And you always write down the formula that you're using. Then you substitute a number. Okay, always get into the habit of write down the formula. Then you substitute. That way, we reduce a lot of mistakes. So 2 pi r is the entire circle, but I don't want the entire circle. I only want this part of it. So I only want 6.23 degrees out of the 360 degrees. Okay. So again, write down the formula that you're using. Now you substitute the numbers in there. The radius is 10. Now you can show your work. Okay, notice I already cancel out the degree with degree. That's how I drop that, right? So you can cancel out the degree with the degree. So that's why it's no more. Okay. So now you get your calculator. Calculator. Okay, so get a calculator, and then you punching all the numbers in there. So 2 times pi. Okay, if you don't have pi, you just use 3.14. Whoa. Okay, times 10 times 6.23 divided by 360, push equal. Okay, so you get 1.08, I think 87. See, this calculator is messed up really bad. Okay, but you have to follow instructions. You have to pay close attention to instructions. It says compute the answer to 2 decimal places. So you have to run it up. So it'd be 1.09, and don't forget the label, right? And you box your answer, and that's it. Okay. Okay, so let's go and do some practice. Okay, so EOO stand for every other odds. Okay, every other odds, you just keep adding 4, right? So it'd be like 1, 5, 9, 13, 17, 21, okay, 25, 29, and so forth, right? Okay, and that's it.